Everybody, let's see if this works. Okay, so hello everybody. I realized that I skipped the stream yesterday, and in fact, okay, so hear me out. I thought I was streaming, I was not, and then I did this entire fucking paper. So yeah, that's basically all that happened. Is I thought I was streaming, and I clicked the stream button on OBS, which should have started streaming, and then it didn't start streaming, and then I was left talking to myself like like a psycho for an hour. Well, not an hour, a little more like 45 minutes, but you get the point. It was pretty embarrassing. So we've made some innovations. We have. So we've got subtitles now. Wonderful. We've got subtitles now. And also, we have got music. I've managed to get music working. So I realized that you're supposed to do some fancy jinking with OBS to make separate audio sources or whatever, but I really can't be arsed. I spent all of yesterday trying to get the audio and stuff working, kind of looking at how you're supposed to do fancy stuff on OBS, and that's why I kind of delayed the stream several times until like 11 p.m., which is when I did this paper. And as a direct result of doing that at 11 p.m., I did terrible. Instead of getting 9 questions correct like I usually do, I got 8 questions correct. So I've pretty much failed at my life purpose. Which is why we are going to be going on an redemption arc today, an anime redemption arc, which is where we do let's see. So we're gonna be doing 2010, obviously, that's the title of the stream, but we are also going to be doing 20, let's see. We are also gonna be doing 20, what was it again? It is 2014. Wait, what the fuck am I doing? Right, no, 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 no. So we're gonna be doing 20. Oh God. What have you done? What in the hell? Okay, okay, let's see. We're doing 2010, of course. We're doing 2014. We're doing 2017. And let's give it a bit of spice. Let's do 2016, right? So we're gonna be doing a oh wait, no. There are one, two, three, four. I can't count. Okay, I'm gonna have to choose not to do one of these papers then. Hmm. Okay, you know what? Let's swap this out for 2011. Check this out too. Okay, so we're doing 2010 and 2017, and then we're taking a lunch break, and then we're gonna do 2011 and 2018. Yes, that makes sense. And you can very clearly see here um that the page itself changes, which is kind of weird. Also, another change that we're gonna make. Previously I did all of section A in 45 minutes, and I realized by doing a bit of math that this doesn't make sense at all. Cause well, look at this, right? The MAT has 10 questions and in 45 minutes, uh so that's 4 minutes and five four and a half minutes per question. And then you have the TMUA, which is 75 minutes, and then it has 20 questions, and that's actually 3.75. So to rectify this, we're going to be doing two papers at once with the 75-minute limit that you have for the TMUA. And first, we are going to be doing it in standard TMUA conditions. You could think of it like that. Yeah. So we started off with an easier paper and then a harder paper, which I don't know. It might not go well, but we'll see. We'll see. I am optimistic about this. Hopefully, we can get like a 16 or 17 or a good score like that. Also, I've got a ruler just prepared here just in case. Okay, well, so let's just quickly modify this. 2017. Let's also edit the title of the stream actually. It's 2017. 3 mini fucks. Right. Okay. So finally, many MAT papers to do. Let us begin. Oh, right, music. Let's see. So Oh no, what is happening? Okay, so today I picked Chimera Dragons by Camilla. I really like this album. I really like this artist in general because he makes noises happen, which makes the noises in my head go away. Wonderful. So, and also a fun fact: this is exactly 45 minutes. So when this ends, we will know that it is also time for us to stop doing things. But I'm gonna rely on this normal timer because we actually do need to do 75 minutes. This probably isn't gonna be something we can afford to cut or afford to be generous on. Okay, so in 3, 2, 1, start here. Go to here and we start. Okay, so switching into exam mode. So, question. Let's see if this works. Oh God, why is this like this? Okay, right. I always forget to do this. 1 second. Okay, boom, boom. Okay, there we go. So, question 1. Right. So the values of k for which line kx with y-intercept of 0 intersects the parabola are precisely. Now we can graph this out very easily. So let's make sure to read the question. So it's something like, oh shit, something like this, right? And then we are translating x squared by -1. So actually it's the other way around. So it's going something like this. So this is 1, 0. Actually, just in case, I'm going to turn this down a little. 1 sec. Because I know that people complain like very frequently about audio being a big thing, so I'm just making sure that we can hear my voice and also the music. That would be nice. Okay, back to the work. So the values of k, which is intersects or d, so we can clearly tell if okay, so we can clearly tell that if k is smaller than 0, then it's probably not going to be able to intersect. So actually, our limits are like something like this, like a line going like this, and a line going like this, right? So this means the only possible option is C. Yeah, because so for all like m where oh no, I mean for all k, which is above 0, that definitely intersects because it's like the lines like these, and for all k where it's smaller than some like constant k, it will intersect the other way around. So therefore, this area is the only place where it can't intersect at all. Okay, so now on to the second question. The sum of the first n terms is okay. So this is two geometric series together. So it's actually 1, 4, and it's actually 1 squared. Hence, we can then work this out as just adding the two together, right? So let's see. The first term is n. The first term is a. Then it is. So that's one of our geometric sequence. That's this geometric sequence, and then the other geometric sequence is simply. Okay, and then this becomes something like this. This becomes something like 2n plus 1 minus 1 minus... Wait, no. Okay, so this becomes 2. Wait, I'm stupid. Right, okay, so that's 2 plus 1 minus this. This, right? Yeah, this makes sense so far. So it's plus 1. Yeah, so it's 8. Okay, well, that makes sense. It's just some simple messing with lock laws. Okay, so in the range, this... okay, in the range from 0 to 2 pi, so a full rotation, the equation, this has a number of solutions. Okay, well, we can first draw out sine graphs. No, that's not how you draw a sine graph. Let's see. So there's no way they can both be 0. What if we convert one of them into cos squared? Actually, no. We should be converting them into sine, because... Yeah, that makes sense. Okay, so... This is now 2 sine squared. So it's 2. Plus sine squared because of that. And 2 sine cos. So we can then kind of throw this over. Yeah, that doesn't make sense. You don't want to throw it over. Okay, so let's throw this over. This doesn't make sense, does it? Okay, what we're trying to do is we're trying to find a number of solutions, right? Genuinely, this is pretty mystifying. Let's see. Okay, so gotta remember to keep talking. Also, I'm gonna turn this down once more. Okay, so let's remember to keep talking, right? Because in an actual Oxbridge interview, we've got to keep talking. We've just got spewing nonsense out of our heads. So in this range, the equation sine squared plus 3 sine cos plus 2 sine plus 2 cos squared equals 0. So we can manipulate this into a way which makes sense. So we're probably gonna have to look at it using graphs and such. I don't think we can solve this directly, so okay, one interesting property is that if you divide the entire thing by sine, then it kind of becomes like no, but that would take away some of the solutions, right? So let's not do that. Oh no, divide the entire thing by cos, sorry. Okay, no, but that's not valid because then you would divide by zero. So let's not do that. It has to have at least one solution. I feel like this is close. Shit. Okay, so it's like this. We're trying to find -2. Actually, since the whole thing is negative, then it becomes more like this, right? Because consider okay, so first of all, this thing is stretched, right? And it becomes yeah, and this part is stretched, and then we're graphing this out. So then it's squared, so it looks kind of weird already, and then it's all negative, so it looks something like that. We're gonna say there's two solutions based off this graph because, like, there's probably one point here where it works, one point here where it works, right? Yeah, that makes sense. I don't think there would be one solution. So let's look at D now. What's our time? We've used too much. Yes, I think too much is the conclusion we should be drawing. So, the graph of sine sine squared x. What the fuck? Okay, so it's not a obviously because it can't go negative. It's not D because it's not linear. Definitely, it's something weird as fuck. So it's either B or it's C. I can't see any reason why it would be C either. Because what you're considering is why would it go why would it go up, right? Why would the like exponential increase like this? Because it's sine, right? At the end of the day, the entire thing is encapsulated in sine, so it's always gonna look something like this. And that's B looks like that. But C does not. So we're gonna say it's most probably B. So E. Which of the following is the largest of the four following numbers? Well, damn it. It's not C. But I have forgotten how to convert bases. So that is inconvenient for me. Let's see if this works. So you're asking me which one of these is the biggest, right? It's definitely not D. Just by pure guesswork. Yes, I know. Guessing is great. And I don't think it's this either, right? Because think about it. 4 1 is 4, 4 2 is 16, right? And so it'd probably be like 4.3 something to be 8. Whereas this, it's probably like 2 point like 0.5 something to be 3. I'd say this is probably the highest. So we're gonna say it's C. Based off nothing but pure ass. Guesswork. I love guesswork. So it's trapezium rule is used to estimate this number by dividing 0. Okay, well, let's graph the fucker. The estimate calculator will equal the actual integral when n. What the fuck? Oh, ooh, this is weird. Oh, so the actual function itself is like weirdly discrete. So, oh, so it's D. That's easy. Okay, because well, think about this, all right? You've got to divide this equally. So, like, can I put something here? Yeah, you've got to divide it here, 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 and so, the presence of the 3, right? It can't be 1/3. You can't divide like 4 or 8 like that. 6 you can divide like this. You can divide like this, but you cannot divide 6 into 4 pieces. So that pretty simply rules it out. It's 12. Yay. G. The function defined for whole positive number is satisfied this. And also the rules f of 2n equals that. Right, so let's draw out a few functions, right? So it's 1, and then it's 2, and then it's 4, and then actually this is also 4, 5. So for 5, n is 2, so that becomes 8. So does n. Okay, well, we can pretty simply graph this out, actually. So for 6, it becomes 8. For 7, it becomes 16. Yeah, this isn't that hard. It's just solving it repeatedly, right? So, yeah, okay. Wait, for 8, actually, it's not going to be 16. Right, because if you divide it by 2, then that's 4, 4, 4, so here. So actually, this is probably going to be 8. Yeah, so the answer is probably B then. Let's look at H. So how many questions do we have left of this paper? Okay, so not that many. Given a positive integer n and a real number k, consider the following equation in x, where x minus 1, x minus 2, x minus 3, blah, 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 until x minus n equals k. So if n equals 3, then the equation has no real solution x. By the way, let's just set this is the timer, by the way. This is the time we have to finish all the paper by. So, if n equals 3, then the equation has no real solution. So, if it's something like this, then it breaks. For some values of k. Okay, so as k goes to infinity, um, as k goes to negative infinity, though, then you can just make this. Okay, some value. Okay, so consider like the extreme values, right? So, like for this, we know these are definitely fulfilled because as x goes to infinity, then k can also go to infinity, right? And as x goes to negative infinity, then k can also go to negative infinity. So it would have to be something in between, if that makes sense. I feel like D can be pretty easily crossed out, right? D can be pretty easily crossed out. So for even for like small cases where it's something like this, no, this should be B, right? Shit, no, 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 that was right. Okay, so even for small cases like this, right? You can consider the graph like this, and if you draw it here, right? If you draw the intercept here, then there's multiple values of x where it will work. Yeah. So D is quite obviously false. C, if k is larger than 0, then the equation has at least one real solution, x. That doesn't seem true. Okay, so cortex and quadratics and stuff have to look like this. Okay. So if k is larger than 0, that puts it upwards. So the question is, can the entire graph be manipulated upwards for any of these values? And I don't think it can, right? Okay, let's consider a small case, like Like this one. Yeah, C can actually turn out to be true. Let's examine what B is. I really don't think it's A, by the way. Because think about the shape of a quintic, right? It's just there's no like for all values of k, it's probably gonna have some value. So where n equals even, the equation has at least a real solution x for any given value of k. That's just blatantly false. Come on. Ta-da! Okay, yeah. So like a quadratic, there are values where k doesn't work, so it's obviously c then. Okay, never mind. So you can just dismiss the ones that are clearly wrong and then find out the answer. Oh fuck. Perfect. Oh no, what's gone wrong? Right. Okay, back to work. So a positive number a lets this funny integral, then integrate that fucker. So is it just this? Shit. Because if you differentiate both sides, then the integral goes away. Then it's just this. Let's say you log both sides, right? You log. Okay, so then it's this, which is weird and bad, and I don't like it. Okay, so that's clearly wrong, because obviously, there is no log in any of the answers, so you can't just differentiate it to make this go away. Which renders me a solution not interesting. But wait, you're differentiating by in respects to A. What the fuck? How the fuck would you do that? So I understand how differentiation works, right? So you've differentiated this. Ooh. Huh? Oh, do you have to like manually solve it first? Then you no, but you can't. Do you know how to do like integrate an exponential? Definitely don't know the chain rule, and you need a chain rule to do that. So, ugh, what the fuck? Genuinely, I have no clue how to do this. Okay, so what you're trying to do is find the derivative. When a equals this, then it equals 0. That doesn't really help me here. What if we audaciously enough just do this? Okay, like this doesn't seem right, but I'm purely guessing here. So when a equals square root 2, so okay, this equals 0, right? Then this becomes minus 4, minus 1, because 7, 0 into here, and then this becomes just 0. Then this becomes 1. So now we're looking at 4 minus a squared, right? And then a has to equal 0, so which is wrong, clearly. So this is just this is all just an incorrect mess. Somehow they pull out surds in this. I'm not sure how they pull out surds. Maybe the solution is just that we pull out random values, right? Hey, wait, legitimately. Do you, okay, I appreciate this might be cheating, but do you, is integrating, is integrating, no, there's no way it's in the spec. Okay, no, let's continue. Genuinely, there's no way that's in the spec. I don't believe it. So there has to be some trick to do this without using bad methods that we don't know how to use. Wait, if you're differentiating this entire mess in respects to A, okay, so this mess should increase by integration in respect to X, and then decrease because they've just got their A taken away. So this really should be, this should be equals to the, like this. So the answer is B. Huh? Okay, whatever. The answer is B now. I don't know. I don't know enough about that. Let A and B and C be positive numbers. There are finally many positive whole numbers x, y, which satisfy this inequality. We have 4 minutes to do this. Okay, there are finitely many positive numbers which satisfy this inequality if let's draw a graph. I love drawing graphs. So this and possibly like so let's see. Okay, so these are two exponential functions, and one of them is multiplied by some constant, and they're both probably different. So what we're looking at here is we're looking at multiple graphs. So this graph doesn't help us at all, right? Let's just ignore that. But we can no, actually we can conclude from this graph that if they are going in different directions, if one of them is above zero, above one, and one of them is below one, then they will definitely be going in different directions. And so definitely there will be a infinite number of numbers that satisfy this inequality, right? So then we can just look at it's either C or it's A. And so for no wait no it's either C or it's B or it's C, right? And then let's look at B because B is curious. So what B is that it is essentially going the other direction. I feel like we've gone down the wrong track of reasoning here. I'm willing to spend a little more time on this question, but not that much. Also, this never goes negative, does it? Actually, it should be more like this, right? Yeah, no, that's the correct answer. Okay, so actually, it needs to go something like this. In order for there to be a finite number of positive numbers. Oh, it's an or an and. Ooh, interesting. So I think at a minimum, we can determine that D is definitely correct. Oh wait, no, D is the only option then. Okay. Sure, this makes me nervous, but let's conclude it at that. Okay. Next, let's move on to 2017. So, let A be this fuck ass cubic. For what values of the real number k does the graph f of x have two real distinct real stationary points? God, that's a lot of words. So, real stationary points. Differentiate, right? Like it's obvious. Differentiate. So we've differentiated this. We need two stationary points, which means that the discriminant has to be above zero for this to have two roots. So discriminant is 4k squared minus 4, 6, 2. This has to be above zero. 48 divided by 4. 12, so it's here, so k has to be larger. So it's this, and it's this, right? So therefore k is smaller than negative, or k is larger than this. Okay, done. Which is B. Okay, well that was easy. Oh god, I'm gonna get that question wrong. Let's see. Minimum, fuck you, not you again. Right. Oh, no, you're a quadratic this time. Oh. No, you're a quartic this time. But you're still a hidden quadratic, so it doesn't matter that much. Still though, you're an ugly bastard, aren't you? OBS keeps disconnecting. I don't know if that's good. I don't think that's good. Let's see. So, minimum value is this. And so we need the smallest value, which is when u equals this, which we can be achieved. Plus it's free, because if this r equals 0, then it's just free. Okay. C, a sequence has a property. So it's a recurrence function where 2, 6 equals a free, which is just free. Okay, so there has to be some kind of loop here, right? So let's see. A1, A2 equals 2, 6. Okay, so A4 equals 3 over 6. Oof. So negative 6, and then this divide by 3. Divide by 3 over 6. Then this is 6, which becomes 2. And this is 6. Okay, so yeah, this is the loop. Starts at 1, ends at 7, so 6. So 2 versus mod 6 is 17, which is 37, which is 1. So it's 2. Okay. Yeah, that seems obvious enough. Let's go to D. It shows a funky graph. I love funky graphs. Daddy funky graphs. And so we've got this funky graph. Oh, so it's just a bunch of inversions, which is not that hard. So what they've done here is they've got this. They've got this. Okay, C, obvious enough. Is this really an MIT question? Watch as I get it wrong. Right, we'll go back and check that later, though. Let a and b equals positive integers such that a plus b equals 20. What's the maximum value that a squared times b can take? Positive integers. That really limits it down. Is 0 an integer? I don't think it is. I mean, no, 0 can't be the value because then it would be just 20 squared 0, so that's not right. So 29 times 1. What's that? Times. Okay, no, this is clearly not right because that's like 20 times 20, which is like 800, which is not anywhere near that value. Okay, so let's actually look at this algebraically then. Okay. So actually, it's something like this, which is the what we need to solve, which is 20 minus a squared. So we just need to find like let's do a derive and let's do a derive the derivative finding behaviors, right? Okay, so the values come out to here. So a is either 0 or a is this, right? And so let's do another one times 2. So it's then this. So where a is equals to 0, so when a is equals to 0, then this mess is smaller than 0. Wait, no, bigger than 0. So it's a minimum. But when it's this, then it's smaller than 0. So it's a maximum. So this is the correct answer. Why is my YouTube music stopped? Yes. So actually it's 450 or 39. So those are the three values we've got to test. So it's either 13 or 14. Okay, let's test. So it's 13, 7, or 14 times 6. So that is just 69 times 7, which is 89 plus that times 2, which is wait. Give me a second, give me a second. Sorry about that. Okay, I'm back. Let's see. Okay, wait. Oh my wow, my pen just went flying. Okay, 1 second. So let's switch it here. All right. Okay. So timer back on. Right. Let's keep doing math. So 16 to 33. So it's either that or it's 14. What's 14 times 14? That's shit. 18 times 68 times 6, which is. Nope. It's most certainly not that. It is. Oh God, why are you making me do math? So it's either this or it's this. This just barely beats him out. Could also just do, this, just to make sure. Yeah, okay, fine. Okay, that was a waste of time. Okay, so back to F. Picture below shows the unicircle where each coordinate has cos x, sine x for some x. Which of the marks arcs? Who respawned? To tan x, cos x. What the fuck? Sure, let's draw a graph. I don't know how it will help, but sure, let's do that. It's arcs, not sectors, right? Uh, so it can't be A, because sine has to be bigger than cos. Also can't be E. Could be D. Let's look at tan then. So tan should also like kind of cross out two options here. Right. Oh, right. I'm on stream. Okay. Wait. Okay. So, we can determine that A and E are out. So now we have to do the hard part, which is figuring out what the hell this means. Okay, so if we turn tan into this as a quantity identity and then we manipulate a bit, we get that. So cos squared has to be bigger than sine. So I think that rules D out. Oh no, it doesn't rule D out. In fact, D might be the more likely option, because so for D, sine is below 1. Cos is definitely below 1. Cos squared. Wait, can you even do this? Because if you're multiplying this, it could be by negative or positive. So you actually know this isn't valid at all. You can't turn this into this. Okay, never mind. So it's still either D, B, or C. And we have, oh god, we've got 4 questions left. Okay, so I'm skipping. Okay, we'll do this later, right? So for G, all values, all angles in the range, this, the line divides a disk into 2 regions. That's a disgusting line. Okay, so what we're looking at here is a classic, not classic, I've never seen this before, but a graphing question, right? It's a circle with a center, that's a disk, and then there's a line. Okay, and again, the cost graphs look like this. Okay. So we've got essentially a bunch of values. Okay, let's start at 0. So if y squared equals 0, then y equals 1, then the thing is not split evenly. Okay, so if, you know, y equals 0, okay, then if pi equals, let's say pi equals this, right? So then that's the answer. So for pi equals 60, actually, it will look a lot like this, which is pretty fucking good. And if this was the largest value, then you'd get it at here, 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 and here. So you get it at four places, essentially. That's a pretty good guess. I'm gonna go with that. Like, low-key, that's a pretty good guess already. Okay. So, in this question, A and B are real numbers. Oh my god. And A is non-zero. When the polynomial is divided by x, then the remainder is 1. Plus, it's got this fucking thing, which is a factor. Ugh. So if A of x is a factor, then 1 over A, so like something like this equals 0, right? When the polynomial is divided, then the remainder is 1. Okay, so when you look at that, then it's more like by so x equals c plus 1, right? So henceforth, we've got that. And A is non-zero. Huh. Oh, A is non-zero because then that's the only way that this makes sense. Okay, so that doesn't tell us anything. So how do we solve this in a way which matters? The C really could be anything, so we are probably gonna have to use both of these in order to solve it. How do we do this? What the fuck? Okay, wait, what? Okay, so we've got this amount of information, but that doesn't really tell us anything. Okay, wait, what if B times C plus 1 equals A over 4? And since we know what B is, I've got no idea from him. Okay, you know what? Let's move on. Let's do this, right? It's a log equation which looks less terrible than the other ones. J is just a graphing question, so J should just take time. And no mistakes, obviously. We're not going back to check the previous questions, I guess. That's not happening. So That's x squared. It has a repeated root when. What the fuck? Okay, it has a repeated root when. The fuck? Genuinely, my head is spinning. What the fuck? Okay, so that is a value. No, we got no. It's negative. This entire thing is negative. What the fuck? That's negative. Logs cannot be negative. We know this. The fuck? What the fuck? Draw above zero. It got a repeated root. Okay, wait. Let's cross all this out. Because actually, this. So discriminant. This has to be bigger than zero. I'm so confused. He is funny. He's a funny solution. I like that. A is hilarious. Wait, so that becomes 2. Okay, let's assume E, right? So that becomes 4. What the fuck? Is that right? Huh? None the fuck. Is that right? Okay, I'm gonna throw up. What the fuck? Uh, huh? Okay, I'm really sorely confused. So, yeah, we've been going for an hour and a bit, which does not bode well for my mental stability. Let's continue. Okay, so we've got J left. Okay, no, no, no. So we've got J left, and we've got H left. So all we need to do is solve these two in 6 minutes. Three, two, one, let's go. Okay, so we're assuming it's E. I know it's probably wrong. I don't really care anymore. Which of the nucleus is the largest value? I'll bet out of my ass it's not C. Okay, so let's do this. So I'll bet out of my ass it's not C, because sine is capped to 1. That's the highest value. Um, you know, that's A. Times was apparently like this. Okay, so it's not A either, because this has a pretty low maximum value. Like at most, it's like here chopped and here chopped, and the area is gonna be really small. So it's not A. I'm going to rapid fire. B probably has like a somewhat consistent value at like here, right? It probably looks like this, right? So that's it, and then that's the line. So B could be a value if all of these turn out to be really small, which probably isn't the case because there is the monstrosity that is D, which is guaranteed to be huge. Sine cubed is going to be negative at once. So sine cubed is gonna be like this. Shit. Yeah, it's going to have negative points, and that's gonna cancel out the positive points. That's the point. Okay, so let's go to H. So B equals a bunch of numbers. Which number does B equal? Right. So we've been able to derive this information and this information. which doesn't tell us much. I forgot the remainder theorem. This is a huge problem. Like, I just don't know the remainder theorem. It's genuinely like it's just not one of the things that came up in my mind. Like, okay, wait, pause. Let's just Google this real quick. Remainder theorem. Give me a sec, fam. I have 1 minute 40. I don't think I'm solving this, but is divided by a linear function. The remainder is the function evaluated at C. That's actually really useful. Okay, let's go. Okay, so if we divide it, then the remainder is 1. So actually, negative b squared minus 2ab. Nope, what the fuck? This is plus a squared is equals to 1. Okay, so now we need to solve this. How the fuck do you do that? A is non-zero, so I'm just gonna go ahead and yeah, might be cooked. It's E, I don't know. Sure. Okay, so that is this live stream's papers over. Well, this live stream. I'm gonna start up a live stream like literally in like 30 seconds, and that's gonna be the same thing. Okay, well that went pretty horrible. My brain kind of fried near the end, so I think that's definitely something that we can work on. So long-term endurance, because in the actual TMUA it's going to be 3 hours, which is horrible. It's going to be 75 minutes, and then instantly after that, it's going to be the next test, which is also 75 minutes. So the entire thing is an hour and 2 hours and half. That does not bode well for me right now. Like right now, I was dying near the end. You could tell. Um, so that I think with a little more time, I would have definitely solved H. So yeah, I mean, regardless, let's just check the answers because which papers did we do? We did 10 and 17, right? 10 and 17. So that's not the solutions. Okay, let's see. Come on, fast up. I think I did alright on 10. I don't think it was the best, but I think it was alright. You know, on the other hand, though, I think I did pretty terrible on 17. So yeah, okay. There's a lot of guesswork in 17. I'll say. So first question is right. C. Second question is A. It's fine. It's D. Son of a bitch. Okay, well, that was quick. Okay, so that's C. That's D. Wait. Did I really just get the correct answer and select the wrong answer? You're mocking me, Sere. Sir, you mock me. Oh, god damn it. Fine. You know, I can't be happy about that, but at the same time, I can't really do anything about it. Okay, now it's time for the questions I actually got wrong. Like D, fine. Wait, what? A little bit. Okay. Okay, wow. Ain't no doing. So let's see. Let's B. Let's D. Okay, well, I got 3 questions wrong. It's pretty bad. Oof. Non-condition today. Sure. Now it's time for the really bad one. Oh no. Oh no. Okay, it's B. It's A. It's D. Why are they so short? C. D. Okay, well, I got the first half right. The damage is limited. Oh, straight up forgot to do F. Oops. The answer is, in fact, B. The answer is H. Okay, you know what? G's a mindfucker. I'm gonna ignore it. Oh man, I got I wrong. Okay, well, D. Somehow managed to get J wrong, even though that was probably the hardest one. Okay, well, I got 4 questions wrong. It does not bode well for the actual team UA. I think definitely the tougher time constraint was a huge unhelp to me here. So definitely doing questions with harder time constraint is less fun. Definitely less fun. We'll say that. But it will be more useful for my training in future. So, you know. Let's see. C is okay, C. Let's take a look at C. So I got this completely wrong. If X solves the equation, then cost cannot be 0. Why not? Oh, because if you consider the graphs, then cost if cost is 0, right? Like here, then sign is a number. Here, when sign is also a number, so they can't be both 0 at the same time. So therefore, you can divide by cost. Therefore, you divide it by cost. Then you find the answer by simply doing math. Well, that's not that hard. This one was just me being an idiot. Read the MCQ voices. Damn, son. Okay. Then this, I fucked up on this one. Okay, well, I just did not realize. Okay, I did not realize. So for the second probability, it matters what orders the rules are supposed. Why does it matter? Oh no, it doesn't. Oh, so yeah, you have multiple permutations. Yeah, okay. Okay, that makes sense. Fine. So you should have just considered this as a recursive function instead of trying to manually solve. Okay, interesting. So consider as recursive function. Divide by cos square since cos square cannot be 0. Solve a 10 quadratic. Okay, interesting. That should be all of the ones I got wrong here. So then let's move on to the first one, which I was rather tough. Let's go take a look at I, actually. Okay, so for I, we have algebraic manipulation, which is a bunch of numbers, and that, so the first term does just cleanly cancel out into x squared. The second term does cleanly cancel out into that. Oh, it's negative. Okay, well, that makes sense. Oh, I just straight up forgot what a repeated root was. So repeated root is when cx minus a squared, right? Like plus a squared. Yeah. Okay. Whoops. Where a is real. Okay. So fuck. I got that wrong. Yeah, I was panicking near the end. So fine. It makes sense that I got it wrong. At least it makes sense. So by the remainder theorem, we can consider some certain things, which is this and that. Which, yeah, I forgot the remainder theorem, so didn't have enough time. Forgot remainder theorem. Oopsie doopsie. I think remainder theorem is in the TMU spec too, so I should get more familiar with it. That it would be wise for me. So let's see. So F and G are hard ones. So if we rewrite, then we get sine divided by cos smaller than sine. So in order to satisfy the inequality, we know that sine cannot be negative. Really? Why is that the case? Okay, well, let's take a look. I don't particularly mind having my answers up right now. So let's see. Oh God, what's happening? No, this is. I want to pull up 27. Right. Why is my music paused again? Yes, I would like to keep watching. Okay, well, let's see. So for F, this for so in order to satisfy the inequality, we know that sine x cannot be negative. Since cos x would also be negative, but tan x would be positive. Oh no, you're looking at the inequality, not the graph, because if sine is negative, then cos has to be smaller. So then cos has to be negative. Okay. So that rules out D and E. If 0 is smaller than cos and sine, 0 is smaller than cos, smaller than sine. 0 is smaller than cos. If 0 is smaller than cos and smaller than sine, okay, where are you pulling these statements out of? Okay, you're just pulling random logic statements out of nowhere. This is what? If 0 is smaller than cos, and also smaller than sine, where have you come this from? Like, the second part makes sense, right? If A then B makes sense. Where'd you get A from? How do you know that true? Because if cosine really is negative as you claim, I mean, it is. I mean, it's an MAT paper. It's not going to be wrong. If it is negative, it's not 0, right? Is it? It's going to be less than 0. So your lower bound for tan has just gone up for no reason. Oh, no, I understand. Okay, so cos being smaller than tan is bad. That's not one of the cases we want. Oh, so what you're saying is, if cos is bigger than 0, then it would be wrong. So therefore, cos cannot be that. So therefore, the answer is C. Ah, interesting. For lambda equals 0, the line is simply y equals 1. Adjusting the angle of this graph alters the gradient of the line. How you figured out that's pivoting, huh? How you figured that out? Oh, I suddenly understand. Okay, so this is what I'm theorizing, right? So what the thing is y minus 1. Oh god, let me just pull it back up. Okay, I forgot immediately. Okay, y cos equals x plus 1 sine cos, right? So what you're saying is sine cos x plus 1 equals y plus 1. So what you're saying is that you're translating the values of x and y. Which is a really trippy way of thinking about it. That makes sense. How would you think of this? That's just magic. Literal magic. Adjusting theta alters the gradient of the line pivoting around a point. So, I mean, surely you must understand. No one's gonna figure that out. What? Wait, does it ask how many ways there are? No, it asks how many values there are. I think a more reasonable way of solving this would have been, right? Consider this, okay? Consider this. Consider this. Come on, come on, work, come on. Okay, my OneNote is severely broken. I'm just gonna close this. Uh, what the? Right, sorry about that. Okay, so let's reopen this and continue to consider our possibilities. Ah, yes, with our high intellect. So, for theta equals 0, the line is simply y equals 1. Adjusting the thing alters the gradient. Now, I want to use decimals in order to figure this out, but this isn't the SAT, so we can't be really using decimals. However, I'd like to consider this analytically, right? So if we consider this, so that's somewhere here, right? That's sine. The sine would stay the same. But cos would be flipped. Horrible, horrible, horrible. So what we'd actually see is this. These cancel out, so it becomes this. So therefore, it becomes this, which is not particularly... Okay, let me just make this graph nicer. So then it becomes this, right? Where it splits the thing in half. Fuck. It splits the thing in half. Very nicely, very nicely. And this is not good for us. It splits it in half. And it's not this, therefore. So therefore, actually, you could have also figured this out by just looking at the graph. Because at what is it? At a bit where both of these are negative, yeah, so at the bit where it crosses over here-ish. So I would take a fair guess, actually, that it's this, that it's 215. or alternatively, you could state this as pi plus pi 1 over 4. So 5 over 4 pi. Yeah. So alternatively, this. And let's try and prove it now using some numbers. So at cosine, this value is equals to negative, right? For cos, this value is also negative. So actually, then these two would cancel out and it'd be the same. Okay, so yeah, you could have done this analytically. I fucked it up. I thought this would be the same. It would not be the same. Well, the value of this would have been the same, but you also have to remember the sign. So actually, this fuck ass solution is ridiculous, and no one is getting that. Like, no one is figuring out the point pivots around here or whatever. That's ridiculous. Come on, that's ridiculous. But you could have done this analytically. I should have done it better. I guess I kind of panicked near the end. I don't know. It is definitely a very weird question. I will say that. It's a weird question. This on the other hand, I really like this question. It's kind of a brain teaser of sorts that you could think about. I just kind of wish that, but I wish I didn't abandon this so early. Like I crossed out A and E, which I think were valid choices to cross out. But yeah, the consideration of this was pretty cool. Like the way they reasoned it, that was cool. And then of course I forgot the remainder theorem, which is never good, and I forgot what a repeated root was, which is also not good. And I just manipulated the logs a bit wrong. So anyways, let's go back. What did I get wrong here? Right. So this one was just stupid as fuck. This one was again one of the questions I liked. I like questions that I get wrong, but which I still understand after like a bit of time, like looking at the answer and working it out. So yeah, this was I forgot the technique to do it. I just need to remember the technique next time. I should be able to get it right. This was a tricky one though. Like, oh, I don't think many people would have gotten this right in the actual exam. Like, damn, son. Anyway, so okay, so that's that. That's this paper done with. Let's now. Fuck. How do I? Let's pull this. No, that's the wrong one. Pull this up. Okay. So let's now pause the music. So that is this live stream over. So now it's been an hour and a bit, and 2 hours, roughly so. And I'm really hungry, so I'm going to go and eat myself some foods, and then I'm gonna come back for the second half, and we're going to do 2018 and 2011. Yep. So yeah, thank you for not watching because there's no one here, but see you in roughly an hour or so. Bye bye.